Sample problem. Two equal charges Q1 equals Q2 equals 2 microcoulomb are located at x equals 0, y equals 0.3 meters and x equals 0, y equals negative 0.3 meters, respectively. What is the magnitude and direction of the total electric force that these charges exert on a third charge Q equals negative 4 microcoulomb located at x equals 0.4 meters and y equals 0? We examine the forces that are being exerted by Q1 and Q2 charges. Since they are the identical, the magnitude of their forces exerted will be the same but oriented indifferently. From the figure we see that the components along x are oriented the same, so the forces along x-axis will add up. However, the components of forces along the y-axis are oriented in the opposite direction, so they cancel each other out. So we sum of forces along x and y as shown here in equation A and B. So the net force exerted on the charge Q is given by C, and simplifying it we have equation D. Applying the equation of electric force 2 and substituting this back we have equation E. Let us determine some of the quantities here. The cosine function and distance are the angle theta is determined by calculating the cosine function by using the geometry of the angle theta. So the function of cosine theta is given by equation F. The distance r is obtained by using Pythagorean theorem. We have equation G. Substituting this back to equation F we have an expression for the cosine function h. Substituting the equations G and H back to equation E we have the resultant force due to the charges to be about 0.46 newtons directed in the x direction as indicated by the unit vector I hat.